Alright, so now that we've done our lab, some other important things we need to talk about are percent composition, how that can apply to an empirical formula, and also molecular formulas. So, percent composition is always going to be by mass. So kind of like empirical formulas, you always need everything in moles. To do percent composition, you always need to know things by mass. So you start by finding your formula mass of the whole thing. So our total mass is going to be 84.313 grams. Right? And then from there, you just find what percentage of that total mass each different atom makes up. Okay? It's kind of like figuring out a weighted grade. Right? If magnesium is tests and carbon is homework and oxygen is labs, you're finding out what percentage of your grade each thing makes up. So ignore this line, it'll change again on the next slide. But you take your molar mass of magnesium, and there's only one of them, and divide it by your total mass, multiply by 100, and your percent composition of magnesium is 28.827%. And you do the same thing with carbon. We have one carbon, so the molar mass of one carbon is going to be 12.001 divided by our total mass, which is 84.313 times 100. You get 14% carbon. Oxygen. Now, oxygen, you do have to include the total amount. So since it's 0.3, you take your 15.999 and multiply it by 3. All right, and then you divide by your total mass, and you get 56% or 57%. Right. The big thing here is a way to double check and make sure you did your percent composition. Make sure your percentages add up to 100. If they don't, then maybe you forgot that, there's 3 oxygens. Because if you plugged in 15.999, then you would have a much smaller number and you wouldn't have 100%. Okay? So always double check your work with percent composition just to make sure you didn't make any mistakes. Okay? So, and then there's 2 major kinds of formulas. There's the empirical formula, which we've been dealing with so far, and that's the lowest whole number ratio. Right? So getting those formula numbers down to the point where it can't be simplified any further. Okay? And then there's the molecular formula, which is going to be the true number of atoms of each kind of element in your particular compound. Okay, because some formulas may have duplicates of the ratio. Okay, so it's kind of simple way of looking at this. Your molecular formula is your empirical formula with a extra subscript, all right, or to a certain number of subscripts. So if the empirical formula is carbon-hydrogen, but the actual formula is C6H6, then this notation for empirical formula to the subscript would just be CH to the 6th. Okay? Things like this, just to give you an example of something you're used to, glucose is C6H12O6. Okay? And that's the molecular formula. Every glucose molecule is made out of 6 carbons, 12 hydrogens, and 6 oxygens. The empirical formula of glucose is CH2O. Alright? And based on how you're doing your experiment, one of these is going to be, typically speaking, you can find the empirical formula first, and then there's a step to getting you to the molecular formula if it's something different. Okay? One nice thing about formulas, ionic compounds, their molecular formula always matches the empirical. Right? And that's because we are canceling out ions to the lowest degree. All right? Like NaCl, you could say Na2Cl2, but then you just have 2 salt molecules. Right? So ionic compounds will always match molecular formula and empirical formula. Covalent compounds that may or may not change. All right, there are some covalent compounds where the empirical matches, like with water. All right, glucose, obviously that one doesn't, and then there's the starch molecule. That one actually does match empirical formula. So it depends. Covalent bonds will definitely get some practice with finding molecular formulas with them. So we've discussed empirical formulas from masses and from experimental data. Another way to determine empirical formulas is from percent composition. So say you are told that this molecule has 20% carbon and 80% oxygen and 10% hydrogen or something like that. You can figure out what the empirical formula would be from those percentages. All this does is add one extra step. Okay? Because our first step before, when we had our grams, was to convert to moles. Alright? We're just adding kind of an extra piece to that first step where you just pretend or imagine that you have 100 grams of sample. Right? The reason for 100 is your percent composition should all add up to 100. So if you say you have 100 grams of the compound, then your percents become masses. Right? Then after that, you determine moles, divide by the smallest number, and then multiply as needed in order to make everything integers. Okay? Example of this, adipic acid contains 49.32% carbon, 43.84% oxygen, and 6.85% hydrogen by mass. What is the empirical formula? Okay? So if we consider that we have a 100 gram sample, all of those percentages now become masses. So to find the molar mass of our carbon, we take 49.32%, make that 49.32 grams, and then divide by the molar mass of carbon, and you get 4.106 moles. We repeat this for each of our different molecules. Okay, so the 6.85% becomes 6.85 grams of hydrogen divided by molar mass of hydrogen. 43.84% of oxygen becomes 43.84 grams of oxygen. So here we have our moles of each element. So we have 4.106, 6.80, and 2.74. So this is the smaller number, the 2.74, so we're going to use that to divide all of our moles to get to our empirical formula. So you do that, we get carbon being essentially 1.5, we get hydrogen being 2.5, and oxygen being 1, which means we will have to double everything to get an actual formula out of this. And we get our empirical formula to be C3H5O2. Okay? Now, this is a covalent compound, so this empirical formula does not necessarily mean it's the actual molecular formula. So in order to find the molecular formula, what you would need to know is your molecular mass of adipic acid. So how many grams there are in 1 mole of adipic acid. Okay? So this is something I would have to give you. You'd have to be able to know what the molecular mass of the compound is in order to determine molecular formula. So when doing that, your first step is to take your empirical formula and find your molecular mass of that. Alright? So our empirical formula has a molecular mass of approximately 73 grams. Alright? Big indicator, if this number doesn't match the molecular mass, then we know we don't actually have our molecular formula. We have to do something with the subscripts in order to get there. So when we notice that these two numbers, the molecular mass of the molecular formula doesn't match the molecular mass of the empirical formula, we have to do another step. You may already see as being evident, to find the molecular formula, you take, or the multiplier that you need to turn the empirical into a molecular formula, you take your known molecular mass and divide by the mass from your empirical formula. So 146 divided by 73 is 2, which means we need 2 empirical formulas to get to our molecular formula. So all we do is take our formula, multiply by 2, or double our subscripts. So therefore, the molecular formula of adipic acid is C6H10O4. Okay, bring any questions that you have to class and try the online assignment to get some practice.